Assalamu alaikum. Today we're starting with vectors in P3. Okay, we are going to make use of all the concepts which we have learned in our O levels. Okay, if I have to define vectors, I would say vectors are directed line segments. Directed because they have direction. Okay, and the word line segment defines that they have a particular length or they have a particular magnitude. Okay, as we go through the questions, we'll be revising a lot of concepts of O levels also. Let's start with this question. We have done in O levels, we've done vectors in 2D. Now we're going to do vectors in 3D. Now for 3D, we need to understand one thing as to what is I, what is J, and what is K. Okay, so I'm writing it here. I is a unit vector. Unit vector meaning a vector of magnitude 1 unit. Okay, a vector whose magnitude is 1 unit. A is a unit vector in the positive direction of x-axis. Okay. Now J is a unit vector. It's a vector of magnitude 1 unit in the positive direction of y-axis. Sorry, this is J. And K is a unit vector in the positive direction of the z-axis. Okay, let's start with this question. I is a vector of unit 1 magnitude 1 unit in the positive direction of x-axis. Okay, so this is I, this is of 1 unit, this is J, which is 1 unit, and this is K, which is also 1 unit. Now if you look at the question, they are saying that this is a cube of edge 6 centimeter. That means every edge, the length, breadth, and height is 6 centimeter. If this is 1I, this whole thing OA is going to be 6I. Okay, and if this is 1J, this whole width of the cube is going to be 6J. And if K is a unit vector in the direction of in the Z direction, okay, or in the third direction, if this is K, this whole thing is going to be 6K. Okay, let's start with the question. It says the diagram shows a cube OABCDEFG has of edge 6 centimeter. Express each of the vectors OE in terms of I, J, and K. Let's do OE first. OE would be, if you go from, okay, OE is when you go from OA to AE. Okay, so I can write OE is OA plus AE. OA is 6I and AE is 6K. Now see, if this is 6K, this is also going to be 6K. If this is 6J, this is also 6J. If this is 6I, this is also going to be 6I. If I have to go in the opposite direction, like if I have to go A to O or B to C, it will be minus 6I. If I have to go from A to J, it will be 6J. But if I have to go from B to A, it will be minus 6J. Likewise, if I have to go from O to D or O to A to E or B to F, it will be 6K. But if I have to come in the opposite direction from F to B or E to A or G to C, that will be minus 6K. Okay, so this is the answer for O to E, because if you want to reach from O to E, you have to go through this path, which is 6I plus 6K. Okay, then the next part is where you have to find out OF. In order to find out O to F, you have to go from O to A to B, and B to F. Okay. Okay, we know O to A is 6I, A to B is 6J, and B to F is 6K. This is the answer to this part. Then we have to do EG. For E to G, you have to go from E to D and then D to G. You can even take the other path in order to go from E to G, you can also go from E to F and then F to G. That's one and the same thing. That is going to yield the same result. So E to G is going to be minus 6i plus 6j. You have to go in the opposite direction of 6i, the minus 6i plus 6j. Okay, then you have to do CE. C to E. Okay, C to E can be minus C to O plus O to A and A to E. So I'm writing minus 6j plus 6i plus 6k. Minus 6j plus 6i plus 6k. This is the answer. Okay, let's do another question. It says OABCD shown in the figure is a prism. The cross section of OABC is a trapezium, and it's said that OC is parallel to AB. OC is parallel to AB. Okay. The cross section is a prism. They're talking about this cross section. We're talking about this cross section. This cross section is a trapezium. Okay, so this is a prism whose cross section is a trapezium. So they're saying, okay, OC is 6 centimeters. I'm just writing it down. 6 centimeter here. OA is 4 centimeters. This is 4 centimeters. AB is 3 centimeters. And OE is 2 centimeters. So these are the measurements which they have already given us. Write down as each of these as a column vector, the first part. Okay, so OC. If I have to go from O to C, which is this. Now, this is the positive direction of x-axis, and one unit vector in the positive direction of x-axis is I. So this is going to be 6i. Okay, OE. I have to go from O to E. This is in the positive direction of the z-axis, and one unit vector is k. So it's going to be 2k. Then you have to find out EF. This is the y direction, okay, and it's parallel to this. So it's going to be, since we know that OA is 4, so it's going to be, and OA, if I ask you to define, you will say 4j, because one unit vector in the positive direction of y-axis is j, so it's going to be 4j then. Okay, the B part, use FC equals to FE plus EO plus OC. Okay, if you want to go from F to C, you will take FE plus EO plus OC, and you have to define FC now. Okay, I'm just writing it in short. I'm not writing this whole thing. I'm going to write FC is going to be, FE is going to be minus 6j. The reason being, if you have to go from E to F, it's plus 4j. But if you come 4j, but if you're coming back, it will be minus 4j. And then you are coming down from E to O, so it's going to be minus 2k. And then you have to go from O to C. So O to C would be 6i. This is the answer. So you can arrange them, 6i minus 4j minus 2k. Okay, then the next part is the C1. Write each of these as column vectors. You have to go from C to J, C to G. Okay, so C to G. I can go, I don't have this vector, so because I can't go from here till here, I don't know what is the magnitude of this. So I'm going to go from C to G. I will go minus 6i I can either go from the base or I can go from the top, whatever. So I'm writing CG is equals to CO plus OE plus EF plus FG. Okay. CO is minus 6i plus OE is 2k, EF is 4j, and FG is in the same direction as OC. Okay, so, and length of AB is parallel to AB, so if this is 3, this is also 3, so it's going to be 3i. plus 3i. So you can add both i's together. Minus 6i plus 3i is minus 3i plus 4j plus 2k. In the vector form, you can even write it like this: minus 3, 4, and 2. Okay, then we move on to FB. Second part, to go from F to B, it's going to be plus 3i minus 2k plus 3i minus 2k. This is FB, F to B. Okay, then I have to find O to G. O to G is going to be O to E plus O to E, which is 2k, plus EF, which is 4j, plus FG, which is 3i. Okay, and the last part, BE. BE is going to be from B to E. Okay, so minus 3i minus 4j plus 2k. Okay, so for B to E, I've gone like this: minus 3i minus 4j and then plus 2k. Find a unit vector in the direction of AD. For that, we have to find out AD first. Okay, in order to find out the unit vector in the direction of any vector, okay, I'll write down the formula here. Formula to find unit vector. Okay, unit vector. So if I have to find out the unit vector of AD, which will be represented by AD with a cap over it, it will be AD, vector AD divided by the magnitude of AD. Okay, we know magnitude of any vector can be found out by the formula, like if this is A and this is B, it will be A square plus B square to get the magnitude. Okay, let's see. Firstly, we'll find out AD. What is AD? AD is, I have to go from A to D. So if I can say, okay, minus 4j plus 6i plus 2k, minus 4j plus 6i plus 4k. Plus 2k. Okay, divided by the magnitude. Magnitude of AD is going to be, since AD is written on the top, I can find out the magnitude of this by squaring minus 4, squaring 6, and squaring 2. So minus 4j plus 6i plus 2k upon magnitude would be 16 plus 36 plus 4, which is mine. If I just write them in order on the top, 6i minus 4j plus 2k divided by the magnitude of this, so 56, square root of 56, and this is going to give me the answer once I solve it. Okay, so we're done with this question. Let's move on to this one. For each of the following pair of points, they're talking about these pair of points. Okay, write down the vector AB. Okay, if I want to find out the vector AB, AB is always going to be OB minus OA. Okay, so you always have to remember one thing, just revising a bit of O levels. XY is going to be OY minus OX. PQ is going to be OQ minus OP. You have to take this vector with O minus this vector with O. There's a reason to it. I can quickly give you the reason. If, for instance, this is a vector P and this is the vector Q, and if I want to go from P to Q, the alternate solution through the origin would be that you go from P to O and then O to Q. Okay, so I can write PQ is equals to PO plus OQ. PO is actually can also be written as minus OP. plus OQ. So in short, we write it like this: OQ minus OP. So for every vector, if you want to break it into its position vector, it will be O with this minus O with this. Okay, so in order to get the vector AB, I will write OB minus OA. Okay, OB is this is written in the coordinate form. If I want to write it in the vector form, it's going to be minus 5 4 can be written as this in the vector form, and minus 10 minus 8 can be written like this in the vector form. Okay, OB minus OA, so minus 5 4 minus 10 minus 8. Okay, let's simplify this. Minus 5 plus 10 is going to be 5, and 4 plus 8 is 12. This is the vector of AB. Now in the second part, I'm supposed to find out the magnitude. I have just discussed it with you. If this is x and this is y, the magnitude will be x square plus y square. So magnitude of AB is represented with the modulus. Okay, so it's going to be 5 square plus 12 square, which is 25 plus 144, which is 169. Square root of 169 is 13. This is the answer. Okay, then we move on to the position vector of the midpoint of AB. For this, you have to concentrate now. Now, assuming this is A and this is B, this is A, this is B, and assuming we're calling that the midpoint of this is M. Now you want to find out the position vector. They're not talking about AM. They're not asking us to find out AM. They're asking for OM, position vector of any point. Okay, position of vector of A is OA, position vector of M is OM, position vector of B is OB. That means starting from the origin to that point. Okay, they're asking for OM, but for finding out OM, okay, first we will find out AM. Okay, we know AM is half of AB. Okay, so I'm writing for the C part, I have to find out OM. Okay, now I'm finding out AM first by saying that AM is half of AB. Okay, we already have the vector of AB with us, which is 5 and 12. Okay, so it's 2.5 and 6. Multiply, this is a scalar outside, so this scalar has to be multiplied with both of them. Half into 5 is 2.5 and half into 6 is half into 12 is 6. This is AM. Once we have AM, O can be anywhere, assuming O is this. And if I want to go from O to M, the other alternate solution is you go from O to A and then A to M. That's what I'm writing here. OM is equals to OA plus AM. Since I already have OA with me and AM with me, I can simply add them up together. OA is minus 10 minus 8, and AM I just found out to be 2.5 and 6. Okay, let's simplify. Minus 10 plus 2.5 is a minus 7.5, and minus 8 plus 6 is a minus 2. Okay, so this is in the vector form. If they're asking us to write down the position vector of the midpoint of AB, okay, we have to write it like this. But if they ask us to write it in the coordinate Cartesian format, then in that case you have to write it like this. Okay, moving on to the next question, which is this. Okay, we know how to find out the equation of the line in the Cartesian form, but right now in order to write it in the vector form, there's a method which we have to follow, and that method says R equals to A plus lambda. You can, in place of lambda, you can use any other alphabet, or you can use mu, lambda, or you can use T or P or whatever. Okay, so this is an unknown thing. R equals to A plus lambda B, where A is a point on the line, okay, the position vector of the point on the line, and B is a vector parallel to this vector, or in other words, I should write the direction vector of the direction vector, which gives you the direction of this vector. Okay, first of all, I already have 2 points on the line, so I can use any one of these. I can use the first one or the second one, any one of them. And for the direction vector, of the line, you have to find out, assumingly if this is A and this is B, so you have to find out AB then. Okay, so in order to find out AB, I will write OB minus OA. Okay, so OB is 4 5 minus OA is 2 1, so the answer is going to be 2 4. Okay, it's not necessary that you give 2 4 only. You can even simplify and give it as 1 2, or you can give it as 3 6, multiplied by any number, like you can write 4 and 8. Okay, but you can use these numbers also. So it's going to be the point on the line, which is 2 1, plus the direction vector lambda times the direction vector. So the lambda is this, direction vector is 2 4. This is going to be the answer to the question. This is the vector equation of the line. This is how we find out the vector equation of the line. Okay, find the equation of each of these lines in vector form. If I want to find out the equation of this in the vector form, we already have a point on the line and we have the direction vector also, so we can write down the formula A plus lambda times B. A, we can take it as a point on the line, which is 2 4 and negative 1, plus lambda times B, which is the direction vector. Okay, so you can write it in the vector. They've asked us to write it in the vector form, so it's going to be like this only. So this is the final answer to this. Okay, but if you want to write it in the other form, Cartesian form, you can write it like this: 4 plus 6 lambda j minus 1 plus 4 lambda times k. Okay, this is called the vector form, and this is the Cartesian form. Okay, determine whether a given point lies on the line. If you want to find out whether a given point lies on the line, what you can actually do is r equals to 1 plus 2 lambda, 3 minus lambda, and 4 plus 0 lambda is 4 only. Write down the point here which is given to you, which you want to check whether it lies on the line or not. Okay, and equate this, the x component with the x component. So 5 equals to 1 plus 2 lambda, get the value of lambda. 2 lambda equals to 4 and lambda equals to 2. You should get the same value of lambda if you equate this y component. So 1 equals to 3 minus lambda, so lambda equals to 2. Yes, if since the value of lambda is the same with both, in the third one we don't have lambda, this should equate if you don't have lambda. So yes, the point lies on the line. The point lies on the coordinates of 3 points are A, B and C. Find a vector equation of the line. Okay, let's find out the vector equation of the line. For that we need the direction vector. Firstly we need AB for that, which is called the direction vector of direction vector. Okay, so AB is OB minus OA. OB I'm writing, which is minus 3, 4 and minus 5, and OA is minus 1, minus 2 and 1. Okay, so it's going to be minus 3 plus 1 is minus 2, 4 plus 2 is 6, and minus 5 minus 1 is a minus 6. So this is AB. Now R equals to A plus lambda times B. A, you can take any one point out of the two, A or B, so I'm taking A, which is minus 1, minus 2 and 1, plus lambda times the direction vector. Okay, the direction vector is given by AB, which is this one. Even if you find out BA, even if you take this as the point B instead of A, and even if instead of taking AB you find out BA, which is OA minus OB, that also is also acceptable, not a problem. So you can write minus 2, 6 and a minus 6 here. This is the answer to the first part of the question. Then they're saying find the coordinates of the midpoint M of AB. Okay, we've done a similar question before, but we can just simply do it very quickly again. Okay, assumingly M is the midpoint of AB, so we already have AB with us, so let's find out AM first. AM is half of AB. AB is minus 2, 6 and negative 6. Okay, so we get minus 1, 3 and minus 3. This is AM. Okay, assumingly O is same, for instance here. So in order to go from O to M, if I want to go from O to M directly, whenever there's a position vector, coordinates of the midpoint of AB, that means coordinate meaning they're asking for OM. So OM is OA plus AM. Okay, so I'm writing it here. OA plus AM, which is minus 1, 3 and minus 3. OA is minus 1, minus 2 and 1. Okay, let's add them up. Minus 1 is minus 2. Minus 2 plus 3 is 1. And 1 minus 3 is a minus 2. This is OM. Okay, then they're saying the point N lies on BC. Okay, let me just quickly take this part down there. It says, let me draw BC first. Assumingly this is BC, just for my understanding. N lies on BC, that means N can be anywhere on this line. Given that 2 times BN is equal, 2 times the magnitude of BN is equals to NC. Okay, that means N is somewhere here such that the 2 times the magnitude of BN is NC. Okay, when you multiply the length of BN by 2, you get NC. That means NC is double of BN. So we can find the equation of the line MN. Okay, for the equation of the line MN, I need the point M and the point N. Oh, the point M I already have with me. I have to find out the point N. That means I have to find out ON. Okay, so I know BN is, actually if this is one part and this is two part, or I can say BN is half of NC. That means the overall number of parts are 3 in BC. So I can say BN is 1/3 of BC. Okay, I can find out BC first. Okay, let me find out BC first. BC is going to be OC minus OB. OC minus OB. Let's write OC. OC is 0, minus 2 and 4. And OB is minus 3, 4 and minus 5. Okay, let's find BC. This is going to be 3 minus 2 minus 4 is a minus 6 and 4 plus 5 is a 9. This is BC. Now I have to find out BN, which is 1/3 of BC. Okay, 1/3 of BC, which is 3, negative 6 and 9. Let's multiply, you get 1, minus 2 and 3. This is BN. Okay. Okay, we already have BN with me. I have BN with me. Now if I want to find out ON, assuming O is here, so I will say OB plus BN is going to be ON. Okay, so I'm writing ON is equals to OB plus BN. I already have OB with me, which is minus 3, 4 and minus 5, plus BN, which is 1, minus 2 and 3. Okay, add them up, you get minus 3 plus 1 is minus 2, 4 minus 2 is 2, minus 4 plus 3 is minus 2. Okay, I already have ON with me. Now since I have ON and OM both with me, I can find out the equation of the line MN. Okay, so I know OM is minus 2, 1 and minus 2. Okay, let's form the equation, which is going to be R equals to A plus, this time I'm using mu. Okay, I can take OM as A, minus 2, 1 and minus 2, plus mu times B. I want the direction vector of OM, which is MN. Sorry, the direction vector of MN. So ON minus OM here. Okay, ON is minus 2, 2 minus 2, minus OM is minus 2, 1 minus 2. Okay, so MN is minus 2 plus 2, which is a 0, 2 minus 1 is 1, and minus 2 plus 2, which is a 0. This is MN. So I'm going to use MN here, 0, 1, and 0. This is the vector equation which they had asked me to find out. Okay, moving on to this question which says find the coordinates of A and B are this. Okay, this is a very similar question. We firstly have to find out the vector equation of the line AB. Then you have to find out whether the point lies on the line or no. Okay, let's find out the vector equation very quickly. Firstly, I'll find out, because I have to find out the vector equation of the line AB, I will find out AB, which is OB minus OA. OB is 2, 1, 3, and OA is minus 2, 4, and 1. Okay, so AB is minus 2 plus 2, which is a 4, 1 minus 4, which is a minus 3, and 3 minus 1, which is a 2. Okay, so the first part vector equation of the line is R equals to A plus lambda B. A plus lambda B. In place of B, I have to write down AB, because this is the direction vector of the line. And in place of A, I'm writing minus 2, 4, and 1. So this first part is done. Then they're saying, does the point this lie on the line? Whenever you want to check, as I told you, you have to equate 6 minus 2 and 7 equals to minus 2 plus lambda, 4 lambda, 4 minus 3 lambda, and 1 plus 2 lambda. Okay, equate the two and the value of lambda should be the same for all of it. So let's solve the first equation here. So it's 4 lambda equals to 6 plus 2, which is 8 lambda is 2 for the first part. Second part, minus 2 equals to 4 minus 3 lambda. So 3 lambda equals to 6. Lambda equals to 2. And for the third part also, 7 equals to 1 plus 2 lambda. So 2 lambda equals to 6. Lambda equals to 3. Since lambda is not the same for all of it, so the point does not lie on the line. Okay, the point does not lie on the line. Okay, and then in the third part they're saying the point N lies on the line AB. Okay, I'm drawing the line AB. The point N lies such that 3 times AN equals to NB. Okay, this is N here. Okay, the length of this 3 times is NB. That means overall, if you divide AB into 4 parts, AN is actually 1/4 of NB. Okay, because NB is 3 times this, so overall 4 parts, and this is 1/4 of the whole thing, and this is 3/4 of. If they ask you for NB, that should be 3/4 of AB. Since they're saying that find the coordinates of N, so for the coordinates of N, first of all, I'm going to find out AN. So AN is 1/4 of AB. I already have AB with me, which is here. 4 minus 3 and 2. Okay, this is 1, this is minus 0.75, and this is 1 upon 4 times 2, which is 0.5. This is AB. AN. Now, wherever O is, in order to find out ON, I have to go, if this is the resultant vector, I have to go from O to A and then A to N. So I can write ON is equals to OA plus AN. OA is, in this question, minus 2, 4, and 1. And AN is 1 minus 0.75 and 0.5. Okay. So ON is going to be minus 1. 4 minus 0.75 is 3.25. And 1 plus 0.5 is a 1.5. This is ON, the coordinates. Okay. So you can write in terms of coordinates, you can write minus 1. In the vector form, it's like this. And in the Cartesian form, you can write minus I plus 3.25j plus 1.5k. This is one. Okay, this brings us to the end of the video. Thanks a lot for watching it.